There we go.
Okay. Did everybody get an agenda when they came in? That's kind of talking about what we're going to talk about today. I also emailed a copy of a lot more of the forms and stuff that we can take a look at, but a lot of it you've already gotten from Dr. McCann about our benchmark results. So we're going to kind of focus on our goals today and what we can do to get our kids proficient in advance. So you've seen this before probably from Dr. McCann. This shows our last year MPI score on the MAP test compared to the previous couple of years. So we got a 339, and Mr. Sutton has set our goal this year to be a 345, so like a 6-point increase. And we had a goal set for us to raise our benchmark scores by 14%, so that's all of us. And so for 8th grade science, that means 64% proficient in advanced kids from last year. We got to get to 78%. So we've got some work to do. We have the highest goal set for any subject because we've shown some success in growing them. So how can we meet our goal? Well, we need to do some thoughtful reflection about our practices. So I went to a meeting last week about our DAP form, and we need to kind of talk about that. You guys have seen this before in the Google Doc. This looks a little bit different, which is why I liked this one better, just because of what it asks us on the strategies, and we're going to talk about that a little bit. It's in your packet, but I also sent you one in your email, so if you wanted to electronically type things in instead of handwriting, we can do that too. This is where teachers have traditionally spent most of their time, is in your PLT, typing in the kids' names and analyzing who's proficient, who's advanced, and who's below. But we're really going to challenge us this year to spend more of our time. If you look at the back of that page where it talks about the SMART goal and the instructional strategies, they're really going to push us to spend a lot of our time on that page. So one of the things you might do is before you come to PLT, type your kids' names in before you come to PLT to analyze who's proficient and advanced on that strand and who needs some extra help, because that will save time so that you and your PLT partners can really focus on the instructional strategies. So I put an example up of 2 different instructional strategies that have been used on DAP forms before. What can you guys tell me, what do you see as differences between those 2? For the same strand, let's say.
The second one definitely has interaction between kids and between teachers.
For sure. I know that I've been guilty in the past of figuring out what my proficient and advanced kids were and then rushing through the end of that form and putting like, we'll review, we'll go back over it. And they really want us to focus on very specific teacher strategies that can push us further. So for instance, if Charlotte and I sat down and looked at our physical chemical changes data, and I did terrible, like my kids scored terrible, and Charlotte's kids were like awesome, knocking it out of the park. So of course we want to sit down and analyze like what's Charlotte doing that I'm not doing. And there's of course vulnerability in that. But when we talk about what she's doing that I'm not doing, like I need to learn, I need to do that, and maybe even like thinking outside of the box where Charlotte and I would switch classrooms for the day, and Charlotte would teach my kids about physical and chemical changes, and I could go work with her kids, because Charlotte's knocking it out of the park, let's say. We have that flexibility, like admin is saying, like we can do what we need to with that. Now we're kind of at an advantage because we have residents that can also like still know our kids, because that I see that as a struggle, because like if I went into your room, I wouldn't know any of your kids, and so that could be like a behavior management thing. But if you guys, when you're analyzing utilizing, think of activities that are amazing, that are working for you, shoot them out to us, because I need anything I can get my hands on to try and make our kids better. So I'm willing to do this, you know, with like card sort activities or switching classrooms, but we kind of need to think outside the box when it comes to how we're going to get our kids to be successful. But we're doing really well. So let me rewind to last year when we gave the 8th grade science pre-test benchmark. And I know I emailed out about this. We had all 100% of our kids below basic on that first science pre-test benchmark last year. This year on that first science pre-test benchmark, meaning like Charlotte and I hadn't really given any instruction, we already had like 10% of our kids at least at the basic level or above. We had 4%, I think, that were proficient. And that's unheard of because we haven't done any science instruction. So that goes back to what 6th and 7th grade, you guys are killing it, doing a really great job because those kids are remembering that coming up to us. And you know their brains reset every night. Like my kids don't even remember their locker combination, but they remembered some of that science stuff you guys taught them, which is amazing. So now Charlotte and I are starting a little bit higher than we were, which is good because we have to grow 14%. Looking at the end of year science benchmarks for 6th and 7th grade, we ended 6th grade with 15% proficient and advanced kids. So with that 14% growth goal at the end of this year, you guys would be at 29 to 30%. 7th grade we ended with 39% proficient and advanced, so that would end up with 53% this year as our goal. And then those numbers I showed you before were wrong. Yeah, so 54 to 68 is the 8th grade data. And then I just want to kind of point something out. There's been some questions as to whether our benchmarks are accurately predicting like our science scores on the MAP test. And so I went back and I looked at data. And so from last year we had 64% proficient and advanced kids on the benchmark. And when we took the MAP test, we had 56% proficient and advanced, so that was fairly close. The previous year that we did the benchmark, we ended the year with 41% proficient and advanced on the end of year benchmark. And our MAP test said we had 47% proficient and advanced. So there are correlates between how they're doing on the benchmark and how they're performing on the MAP test. So if we just keep pushing these numbers up, we're going to be really hugely successful. So let's look at what we're doing really well. So when I look at where we scored highest on, and I'll send this to you guys because you can't probably read this very well. These are strands that we scored really well on that 8th grade pre-test benchmark. So this is saying like 6th grade is doing a fantastic job with the beneficial and harmful activities, the effective human activities, and adaptations. Like our kids are knocking it out of the park with those strands, even in 8th grade, so 2 years separate. 7th grade, they are, and this surprised the you-know-what out of me, they are doing so good with forces, types of forces, and simple machines, which is fantastic because I think that's a pretty big section of the MAP test. And that's great because that's really hard for them, but that's one of the areas we scored really well on, the 8th grade science benchmark. So they're remembering that coming up, which is fantastic. And then we had a couple of 8th grade strands on there about evidence of energy transformations, which is coded as an 8th grade strand, but that's really like a 7th grade topic. And kinetic theory and rock and fossil evidence. Do you guys talk about rocks and fossils in 6th grade? Yeah, yes, that's probably why.
Fossils,
Not so much fossils.
But
That's probably why they.
This year's 8th graders might have still got it. So we did talk about.
we did, and they took it out.
Yeah, so that's probably why they did well on that too, because you guys talked about that before. But Charlotte and I really didn't have any hand in any of this yet. So this is all you guys doing a really good job. So those are things that we're doing really well. And then branching from what we're doing really well, what can we do better? Okay, so in your packet, you have a template that you're going to recognize from Dr. McCann's worksheet activity he did with us. That's I think the last thing I put in there. And then one that I created is before that, the one that starts with I wonder with the question mark. I sent that to you electronically so that you guys can change it to fit your needs, because I imagine our younger students probably need more scaffolding. But this was an inquiry lab where I let the kids decide their procedures, what their experiment was. They were all testing the same thing. So in this case, talking about physical changes, they were looking at what could affect the solubility of sugar. So I told them that's our experiment, is solubility of sugar. But besides that, they figured the rest of this out themselves. It did take, so that we're all on the same page, it did take an intense amount of time. So this lab took me 3 days. So it took me a day of just using this pre-thing to work through the inquiry piece with them. So where we would say, well, what do you wonder about the solubility of sugar cubes? Trying to get them to write a testable question. And I would give them 2 minutes to talk at their tables, figure it out, and then we'd come back together and talk. This took like a whole class period, doing the pre-work, figuring out IV, DV. Now, the good thing is this, the more practice they get, the less time it's going to take. So now that we've worked through this once, hopefully the next time it's not as, pull my hair out. So this was, and my kids, the feedback I got from my students was, at the end of the day that we actually did the experiment, the second day, they really liked being able to design their own experiment. And I know this probably sounds dumb, especially because I'm an 8th grade science teacher, but I really never thought that I could get my kids to do something like this, or me even to a point where I could do something like this where they were writing their own procedures. And I say that because when I give them a lab with written procedures, we fumble the ball a lot. I'm just going to be honest with you. And there was some fumbling in this too. But I feel like where a lot of the learning happened with this lab was my kids messing up. Where when we got done, they realized they hadn't held things constant. And so then they're like, oh my gosh. And so Charlotte and I kind of talked about it in our PLT. I think they finally are starting to realize why constants are so important. Before, they didn't really realize it until they got to the end of the lab and they didn't really have any results because they had messed up their experiment. And again, I gave this to you guys electronically because you might want to scaffold it some more with since your kids are younger. And then take some of those scaffolds out as the year progresses. In addition, something that I think is going to be huge is Charlotte and I have started, when we give our kids a data table, just giving them these blank boxes, because on the map test, and have you guys gotten on the DESE map test, the one that they let you practice on? Have you guys gotten on that? When they make their data table, it's just this big thing of boxes. And something that's thrown our kids in the past is they think they need to use every box. So when they see this, then they have no idea what they're doing. They're trying to put random things in that make no sense. So we've been trying to just give them these boxes, they have too many, and have them create their own data table so they can kind of see what makes sense. And it also reinforces us being able to go through and say, every number needs a label. They're just putting random numbers down in here, at least my kids are. Random numbers in here, and I don't know what you're measuring. They have to put labels on there, unit labels. And then leaving their graph blank without a line for a title and labels, which is probably harder than the map test, because I think the map test has spaces for them to type it in. But if we can drill in this part, they're going to be so much more successful when they see it on the map test, because they've seen it before. And they're going to be doing the work that, scientists make their own data table in their lab notebooks. They're not printing one that says, oh, time in this column, So I also put the one that McKeon put in there because it's cuter than mine, number 1. And it's a little bit more scaffolded. That's also in your email so that you guys can look at that. It's a little bit more scaffolded than the one I did. Because it kind of labels the variables and all that good stuff. And it doesn't go as in depth because I had a place to list materials, I had a place to list, does this one have controls and constants? I can't remember. A little bit. And it kind of scaffolds them writing their hypothesis. Okay? So there's that. I feel like we're going to probably talk about that a little bit more here. There's also a giant push for us to do more project-based learning with our kids. So we're looking at doing a performance assessment, like a week on a performance assessment where their assessment is basically this project that they're doing, and then we just spend maybe 30 minutes on a real short multiple choice quiz part, but the majority of the actual test day would be a performance event with a data table, they graph it, they analyze what's the IBD. That would be the majority of the test, but the whole week is the test, and we do like a performance assessment. So for instance, John and I were talking about doing a performance assessment where we assign the kids compounds that are within certain classes. So like 4 kids get a compound, different compounds, but they're all sweeteners. 4 kids get different compounds that are fuels. And they do research pros and cons on that fuel or that sweetener. They make a movie, they make a model of the compound, and then our culminating thing where they're debating each other on which sweetener is the best or worst, based on the research that they've done. Really talking about the elements combined to form compounds. So the more hands-on stuff they can do, that's like scientists, the better. They're going to get better and better with that. I want to talk more about that assessment. Would you guys have any ideas on how to make them better scientists? And what have we been trying that's been working? What are we struggling with?
As far as that performance event, that one of the things that I've done, and you can say it's working or it's not, because I haven't gotten all the way through it, but
Right.
I'm gonna do the written assessment part, and then after that, my kids are going to design their own lab based on
That's good.
the labs that we've done through class.
Right.
So they already know that their culminating project is to create their own experiment, and they can do it. One of the questions I always ask after we finish with a lab is,
Right.
where will I test next?
Right.
And so they are generating their own list
That's
right
fantastic.
now of what they will test next, and then they get to decide as a group of 4
Yeah.
what they're going to assess. They're going to come up with it more scaffolded than this,
Right.
because we've just started it this year.
Right.
The beginning
Sure.
year. So it's much more scaffolded than this.
Mm-hmm.
But I can also say from some of the labs that I'm doing, there's some scaffolding and then there's lots of blanks.
Sure.
So they have to,
That's
my
good.
goal is that they will have to pick in certain parts where they're gonna have to, procedurally, I put the procedures up there, but
Right.
they are still doing the hypothesis, they're still doing.
Right.
And so in the end, my goal is that they create their own stuff, their own
So
project.
fantastic.
And like I said, I don't know if it's gonna work, I may fall on my face, but I'm
Right.
trying.
Well, the thing is though, and I'm gonna be honest, I think 2 hours, so 2 out of my 4 hours, it didn't go well. It didn't go well, and I learned a lot about, with those specific classes, what I'm gonna have to do better to make that a more successful lab structure. But I do feel like, even though it didn't go well, they're getting smarter hopefully about the process. I mean, if we can get them smarter about the process. And the MAP test is 25% scientific inquiry, basically. And the other 75 is all this sort of multiple choice, fill in the blank stuff that we're responsible for teaching them over the 3 years. But we know 25% is them doing scientific inquiry. And that's amazing because if we're starting to do where they're designing their own labs from 6th grade on up, they're just going to get so much smarter coming on up. It's going to be a much easier job to get them to think about it. Because I don't know about you, but when I first started doing this, it's sort of like pulling some teeth a little bit to try and get them to write their own testable question. that's not a hypothesis. For some reason, they're getting my testable question and hypothesis completely confused. We talked about, even though testable question has the word question inside of it, it's like, I don't know. But I feel like if we're working that up, they're only going to get smarter and smarter about how to do that. I'll turn these off and we can talk.